Yeah, so the shame board, if you had to borrow a pencil, we will all shame you publicly. We'll all say shame. All right, so today's date is Tuesday, December 10th, 12/10, 2019. We're on lesson 6-6, solving exponential equations. Without the use of logarithms, I might add, especially if we're watching this in the future. So, our objective, quiet raised hand. Who's got it first? Beverly was the first one up.
Use properties of exponents to solve exponential equations.
There it is. So we're using those properties instead of logarithms. Logarithms will be that fun thing later in January. So here's the strat. The strategy is to make sure if it's equal to 1, then you obviously know what's going on. The power must be what if it's equal to 1? You can kind of see in example 1. I have some random thing, it looks like it's really tough, but it's equal to 1. That means that the power must be what? With a quiet raised hand, Anna? 0. Oh, there it is. Anything to the power of 0 is 1. You can write that over here. You can say anything. Anything to the power of 0 is equal to 1. And that's kind of the key takeaway, because I think about a third of the homework problems are equal to 1. And then the other 2/3 are kind of the harder ones. And that's where you use the second part of the strategy. So make sure that you get the same base on the left and the right. So like example 2 and example 3, they are both 3 and 27, 7 and 1/49. They can be written in the same base. So first get them in the same base, and then, since the bases are equal, the powers must also be, quiet raised hand. If the bases are equal, Caroline, the powers must be equal. There they are. And I'm sure that's going to confuse probably, I'm going to guess, 3 of us today. Where if I get the bases equal to each other, then I totally ignore them and I purely look at their exponents. So let's do example 1. I'm solving the exponential equation for x. So with a quiet raised hand, what must 3x minus 2 be equal to? Ellery? 0. So that's literally what I write. I say, okay, that 3x minus 2 must be equal to 0. And I've now changed this from an exponential equation into a simple Algebra 1 equation that I think you learn maybe day 3 of Algebra 1. All right, so 3x minus 2 is equal to 0. Quiet raised hand walks through how to solve that. Someone that has a card, hopefully. Ellery and Beverly are already in. India?
Okay, so you change the 3x minus 2 to 0 on the outside, and when you multiply the two numbers by 0 for the exponent, you get 1 over 1, which is just 1.
I think I'm asking the wrong question. Can you please solve the equation 3x minus 2 is equal to 0?
Okay, so minus 2 on both sides, plus 2 on both sides.
Plus 2, plus 2.
And then we'll get 3x equals to 2. You divide by 3 on both sides. And then you get x equals 2/3.
There it is. X is equal to 2/3, and there's our final answer. And you will get lots and lots of fractions today on the homework, so be ready for that. All right. This is the time to ask questions. We're going to move on to a slightly harder type of problem. All right, here we go. Example number 2.
Oh, wait, that's all you have to do?
That's it, done.
Oh.
Yeah.
Okay.
Yeah, when it's equal to 1, it's nice. But it's hard to remember, like, oh, it's equal to 1? How do I get the same base? I can't get 153 over 256 to have the same base as 1. It's like, oh, there's an easier trick. All right, number 2. There's only one tonight. Yeah, every single, today and tomorrow, are the last 2 new things that we're learning, and each of them have 1 homework assignment apiece. Example number 2, we're solving this exponential equation again for x. So now I need to use the strategy of getting them to the same base. If they both have the same base, then I set their exponents equal to one another. So how do I get the right-hand side to have the same base as the left-hand side? Does anyone have their card still? Oscar. Oh, question. Yeah, Oscar.
Yeah, but this is not related. I'm sorry. But when
Can you maybe ask it after the lesson? Write down your question or some note so you can remember your question after. Beverly. 3 to the power of 3, and that's all to the power of 7/3. All right, and then we're going to copy down the left-hand side. That's still 3 to the power of 4x plus 5. That left-hand side did not change. Right-hand side, all we changed was the fact that 27 is the same thing as 3 to the power of 3. Loria, question. Say it one more time.
Where does that come from?
So it's that table that we learned in lesson 6-2, where you just have to have them memorized. 3 to the power of 3 is 27. 3 to the power of 4 is 81. You just have to have these guys memorized now. And it is hard. Maybe it's a table worth printing out, right? You should also know 2 to the power of 7, 2 to the power of 5. All of those, well, they'll help immensely. And you should obviously know your squares. The only squares that I'm going to quiz you guys on in terms of the homework, is all going to be up there. All the squares and cubes that you ever need to know in my class are up there. But I don't have anything higher powers listed up here. Maybe that's a poster for Arrow to make in the future. So now I'm going to use properties of exponents. I need to simplify the right-hand side. How? Anna, go for it.
We need to multiply 3 times 3 7/3.
Perfect. And that's technically 3 over 1 times 7/3. And I just multiply straight through. So can you multiply that for us, Anna, and reduce?
So that would be 3 for 21/3.
Yep, this was equal to 21 over 3. And 21 over 3 reduces to?
7/3. 7/1.
Yep, just 7. Nice. And another way of doing that is I could have just cross-canceled them. I guess I can zoom in here. I don't know why I'm always zoomed so far out. These 3's, I could have just canceled them out and said, yeah, it's 7. And that's our little shortcut. So the right-hand side is now 3 to the power of 7 after multiplying these exponents, because a power to the power means multiplying. Left-hand side stays the same, 3 to the power of 4x plus 5. And this is where that cool trick comes in. If the bases are the same, the exponents must be the same, which means this 4x plus 5 must be equal to 7. I'll write that out for you. 4x plus 5 must be equal to 7. We have now gone from an exponential equation into a linear equation, something that you do know how to solve.
So why do we know that those two are equal?
So in order, you can think of this thing as a scale, right? In order for the left-hand side to weigh as much as the right-hand side, they must be the same exact weight. Well, these are the same, 3 and 3. The only other thing that has to match is this 4x plus 5 has to match the 7. So that's what I'm saying. This 4x plus 5 has to match the 7. Other questions? All right, and then quiet raise hand, last person to solve this problem. Who's got this? India?
You're going to have -5 on both sides, and it's going to be 4x equals 2. And then you're going to divide 4 on both sides, and you're going to get x equals 2 over 4, which reduces to 1/2.
There it is. Thank you.
So that's the answer.
That's the answer, 1/2. And in about 10 seconds, we're going to move on to example 3, which I consider to be the hardest type of problem. It's hard because there's fractions. The more fractions, the harder, right? All right, so we are now on to example number 3. It looks like I have a base of 7, a base of 1 over 49. Those bases do not match. I need to get both of those bases to be the same. So I will give you a hint off to the side as well. And if you don't remember this, if I say 1 over x to the power of n is the same thing as x to the power of negative n. In order to get rid of a fraction on this left-hand side, I can rewrite it with a negative power now, or distribute a negative into all of that power. Ellery, question?
No,
Oh. You ready to answer? Or?
Yeah.
Oh. Okay. Yeah, Ellery, take it away.
So you would have 1 over 7 to the negative squared, right? So
It's still squared. You're about to turn it into a non-fraction by changing it to a negative,
Oh,
which is
because
it's the-
7 squared is 49, so you put that so they'll have the same base. And then it's 2 minus x. And then you flip it, so you have negative 7 squared to the 2 minus x.
there it is. Yeah. So I'll write that out in 2 steps to make sure that everyone can follow you. Ellery's first step is just saying, hey, 49 is the same thing as 7 squared. And I think we can all nod our heads. Yeah, 7 squared, 49. I know that one. The hard part is using this yellow rule that I just wrote underneath example 3, which is I'm going to now flip this. It was a fraction, and I'm going to make it a non-fraction by making a negative power. And that's exactly what Ellery said. This is now going to be 7 to the power of negative 2. That's that parentheses. I've recopied down the parentheses. It was 1 over 7 squared, now it's 7 to the negative 2. Those are the same thing using rules of exponents. And then she copied down the rest of the problem, which was 2 minus x. And on the left-hand side, I still have the 7 to the power of 3x minus 1.
You looked at me like I was going to say something.
Can we take the out?
Can you wait like 5 minutes?
Sure. Yeah.
Cool, thanks. We'll be done by the notes, or with the notes in 5 minutes. All right, so I now have on the right-hand side a power to a power. What operation with a quiet raised hand? And then you're going to do the operation. With a quiet raised hand, what am I going to do with that right-hand side? I have the same 4 people over and over again. Anyone new want to try this one? I'll help you through it. Colby, yeah.
Would be negative 4 plus x, 7 to the negative 4 plus x.
There is 7 to the negative 4 plus x. And the left-hand side hasn't changed. That's still 7 to the power of 3x minus 1. Again, just making sure that everyone can follow Colby's work. I'll get your, is it a question?
I think
Wait,
I found
no.
an error.
Yeah, it'd be 2. It'd be 2x, right?
Ah, yes. (2x) is equal to 7 to the power of 3x minus 1. Yeah, thank you, India. Did you get the XP for attention sooner? All right, so making sure everyone follows along, we distribute this negative 2 times 2 to get the negative 4. Negative 2 times negative x is positive 2x. We're distributing. All right, and we're basically done. We now need to just boil it down. The hardest part is getting same bases. Once I get the same bases, all the hard work has been done. What's the next step? Quiet raised hand. Ellery.
Set 3x minus 1 equal to negative 4 plus 2.
Exactly. We're setting those powers equal to one another.
Should I solve?
Yes, please.
So you would start by subtracting 2x from the right hand side on both sides. So you'll have x minus 1 is equal to negative 4. And you add the 1 on both sides. So you'll have x is equal to negative 3.
There it is. Thank you, Ellery. So I know a lot of people are still copying this down. This is a good time for questions. I'll give you guys about 10 seconds to think about questions. While you're thinking of questions to ask me, I would really love for a question. I'm now going to go back to our objective and do a fist of 5. So our objective was use properties of exponents to solve exponential equations. So how well can you solve these exponential equations on a fist of 5? I'm seeing a 4.5, a 5, a 5, a 4, a 4, a 5, a 5, a 4, a 4, a 3, a 4. Oscar. 3. Chewy's at, or sorry, Leo's at 2 and 2.5. Okay. So the scores will just be improved slowly with the homework. All right, that concludes this lesson.